What if, one day, humanity could grab the field like a blanket, tug it, twist it, and use it to generate power, propel objects, or even reduce weight? What kind of world would we be living in if we could manipulate the very fabric of space itself? In the energy filament theory, we're already doing a small-scale version of field engineering today, but we're still far from casually shaping the field or manipulating tension at will. This episode explores what field engineering could look like in the future, but we'll stay within the boundaries of what's realistically possible at this stage. In fact, you are already engaging in a form of field engineering every single day, albeit a very simplified version. For instance, consider magnetic resonance imaging (MRI). MRI uses strong magnetic fields to align the energy C within your body, allowing us to detect the faintest signals and then reconstructing them into detailed images of your internal structures. Similarly, particle accelerators use magnets and electric fields to carve out the optimal path for high-energy particles. These particles are not traveling randomly through space, they are following a precise, man-made maps within the fields that directs their motion. Then there's magnetic confinement and nuclear fusion, which is even more remarkable. It uses a powerful magnetic field to trap extremely hot plasma, essentially creating an invisible container to keep the plasma confined while it undergoes fusion. These are all real, practical examples of using field engineering to control the behavior of energy, particles, and matter in controlled, purposeful ways. Looking even further ahead, we have some truly innovative field design concepts currently being developed. Metamaterials and photonic crystals, for example, manipulate the microscopic structures inside materials in such a way that specific field modes are allowed to pass through, while others are blocked or bent in different directions. These materials are already being used to create invisibility cloaks, superlenses, and directional antennas. Wireless charging systems and high-efficiency antennas also rely on careful manipulation of fields to guide energy in the most efficient path possible. This is all based on well-understood electromagnetic field theory and materials science. And these innovations are already having an impact on technology today. But what if we dared to imagine something even more radical? True field engineering. What if, one day, we could precisely control tension and thresholds in space-time, creating propulsion methods far more efficient than solar sails or I-don't engines? What if we could design macroscopic tension corridors in artificial structures, allowing energy, particles, and information to travel along nearly lossless pathways, creating a system of super-efficient transport within a structure? At this point, however, we must draw a clear line. In the realm of known physics, the fields we can reliably control are still limited to electromagnetism. The active manipulation of large-scale tension fields, like gravity, remains purely theoretical and has not yet been demonstrated experimentally. Concepts like anti-gravity fields, freely bending gravity, or large-scale tension manipulation are intriguing but currently lack experimental support. They remain speculative, theoretical ideas for the future of physics, not viable solutions for today's engineering challenges. So, while we can certainly explore the possibilities of field engineering, we must make an important distinction between two categories. One is the serious, practical engineering we're already doing today, such as magnetic confinements, precision antennas, and metamaterials, all of which focus on designing the action modes of the energy C. The other is a long-term vision, speculative in nature, that envisions how we might one day sculpt this energy C to create new, advanced technologies. The most sensible approach right now is to focus on perfecting the field engineering technologies we already have and then see if, in the future, the universe will allow us to access even more usable actions within the field. Tap follow, share it on New Physics, Clear Universe.